So in this video, we will discuss the idea of conditional independence. So here's the question. We've got three discrete random variables here and information about their distribution. Question is it true that x1, x2 are independent, conditionally independent given C, both, or neither? So to answer this question, let's look at the definition of independence and conditional independence. Two random variables are independent if their joint distribution can be decomposed into a product of their individual distributions. And conditional independence, this definition here looks really similar to the independence definition. The difference here is we have this conditioning on C. And in fact, conditional independence and independence, these are two completely different concepts, and a distribution can be independent without the conditional independence property and vice versa. So to show that conditional independence does not imply independence, let's come up with a distribution that has the conditional independence property but does not have the independence property. So let's come up with such a distribution. So because we need this conditional independence distribution, this first probability here, I should be able to decompose into these two terms. And I'm making up this distribution. So let's make up some number. Let's make this probability 0.8 and this one 0.4. So then the product is 0.32. Now moving on to the second part, the second equation here. This first term here, we've actually already defined 0.8. The second term here is actually already tied to this probability that we've defined previously, because x2 can only be either 0 or 1. So this probability is going to be 0.6. And we can keep going. So this is going to be 0.2 times 0.4 and 0.2 times 0.6. All right, so this covers the case when C is equal to 0. And because these four probabilities covers the possible values of x1 and x2, these four values should sum up to 1, which it does. So moving on to the case when C is equal to 1. So again, I have this decomposition, and now my probabilities are not tied to any values that we've seen before, so we can make up some new numbers. So let's say this is 0.7 and this is 0.3. All right, so that's going to give me 0.21. And likewise, here I'm going to get 0.49. And here I'll get 0.09 and 0.21. There's one other value that I need to specify, which is what is the probability that my C is equal to 0, and let's say that's going to be 0.3. Okay, so that's all good so far. Now, how do we show that this distribution, although it has the conditional independence property, that x1 and x2 are not independent? Well, to do that, let's we'll need to compute two values, right? We'll need to compute probability that x1 is equal to 1, probability that, I really need the joint probability here. X1 equals to 1 and x2 is equal to 1. You could use other combinations as well. And I want to show, is this equal to probability that x1 is equal to 1 times probability that x2 is equal to 1. Well, let's compute the left-hand side here. So to compute the left-hand side, this term, I can marginalize out C, right? So I can add the conditioning on C is equal to 1 times the probability that C is equal to 1, and same thing for C equal to 0. And since those are the only possible values of C, I just need to add up these two numbers. And this number from the previous page, I believe, was 0.32. 0.32. And this term was 0.21, right here. Times the probability that C is equal to 1 and C equals to 0. And this is going to give me some value here. I think it's 0.243. All right, what about the probability that X is equal to 1? Again, I can do the same thing and sum over the possible values of C. X1 equals 1 given C equals to 0 times the probability that C is equal to 0. Well, this term, going back to the previous slide, was this value. I'm also going to need this value here, 0.8, 0.7, and this should give me 0.73. So we got one more term left, and this is going to be this number, 0.4 times this 0.3 here, plus going back to the previous slide, this number, 0.3 times this 0.7 here, and this one should give me 0.33. And the question is, when we multiply 0.73 times 0.33, do we get the same value as this one? And the answer is no, we get a different value, right? These are different. So independence and conditional independence are not the same thing. Conditional independence does not imply independence.